Look up at the night sky far from city lights. On a clear night you'll see a faint band of light stretching across the heavens. That's the Milky Way, our galaxy, a vast collection of stars, gas, dust and planets, all held together by gravity. It's a cosmic city teeming with activity, a place of birth, death, and transformation. We are part of this grand cosmic dance, living on a planet orbiting a star within this magnificent structure. The Milky Way has been a source of wonder and mystery for millennia. Ancient civilizations wove stories about it, seeing it as a river of milk, a celestial pathway, or the backbone of the night. Today we explore the Milky Way with powerful telescopes and sophisticated instruments, piecing together its secrets and marveling at its grandeur. Our understanding of the Milky Way has evolved dramatically over the centuries. From early observations with the naked eye to modern-day studies using advanced telescopes, we've come a long way in unraveling the mysteries of our galaxy. Yet the Milky Way continues to surprise us, revealing new wonders and challenging our understanding of the cosmos. In this exploration of the Milky Way, we'll embark on a journey through its structure, its components, and its history. We'll delve into the heart of our galaxy, where a supermassive black hole lurks, and explore the vast spiral arms that stretch out from the center. At the very center of the Milky Way lies a mysterious and powerful object, a supermassive black hole known as Sagittarius A asterisk, pronounced Sagittarius A star. This behemoth is a region of space-time where gravity is so strong that nothing, not even light, can escape its grasp. Black holes are fascinating objects that challenge our understanding of physics. Sagittarius A asterisk is about 4 million times more massive than our Sun, and is surrounded by a swirling disk of hot gas and dust. As this material spirals inward toward the black hole, it heats up and emits intense radiation, making the galactic center a bright source of radio waves and X-rays. While we cannot see the black hole directly, we can observe its effects on the surrounding material. The presence of Sagittarius A asterisk has a profound influence on the surrounding region of the galaxy. Its immense gravity affects the orbits of stars and gas clouds, shaping the dynamics of the galactic center. The study of Sagittarius A asterisk and its environment provides valuable insights into the behavior of matter under extreme gravitational conditions. Astronomers have been studying Sagittarius A asterisk for decades, using a variety of telescopes to observe its properties and learn more about its role in the evolution of the Milky Way. By tracking the movements of stars orbiting the black hole, astronomers have been able to determine its mass and size with remarkable accuracy. These observations have also provided evidence for the existence of a black hole event horizon, the point of no return beyond which nothing can escape. The Milky Way's spiral arms are not just beautiful to look at, they are also regions of intense star formation, where gas and dust are compressed, giving rise to new generations of stars and planetary systems. These arms, like the Orion arm where our solar system resides, are a tapestry of celestial objects, each with its own story to tell. The spiral arms are home to a variety of star clusters, groups of stars that formed from the same giant molecular cloud. These clusters come in different sizes and ages, offering astronomers a glimpse into the star formation history of the galaxy. Some clusters are young and compact, still embedded in the gas and dust from which they formed. Others are old and dispersed, their stars spread out over vast distances. Nebulae, vast clouds of gas and dust, are another prominent feature of the spiral arms. These clouds are illuminated by the light of nearby stars, creating breathtaking displays of color and light. Some nebulae are stellar nurseries where new stars are born. Others are the remnants of supernova explosions, the violent deaths of massive stars. Molecular clouds, dense and cold regions of the interstellar medium, are the birthplaces of stars. These clouds are composed mostly of molecular hydrogen, the raw material from which stars form. When a molecular cloud collapses under its own gravity, it fragments into smaller clumps, each of which can potentially become a star. Section 5. The Halo and Ethereal Embrace. Surrounding the Milky Way's disk and central bulge is a vast spherical halo, a ghostly realm populated by ancient stars and enigmatic dark matter. This halo is like a time capsule, preserving remnants of the galaxy's early history. It's a region of faint starlight where globular clusters, ancient stellar swarms, trace out the Milky Way's gravitational embrace. Globular clusters are some of the oldest objects in the universe, dating back to the early epochs of galaxy formation. These clusters are tightly bound by gravity, their stars crammed together in a spherical ball. Studying globular clusters provides insights into the early universe and the processes that led to the formation of galaxies. The halo is also thought to contain vast amounts of dark matter, an invisible substance that doesn't interact with light. While we can't see dark matter directly, its gravitational influence is evident in the rotation of galaxies and the motions of stars within them. The nature and properties of dark matter remain one of the biggest mysteries in modern astrophysics. The halo is not a static region but is constantly being enriched by streams of stars and gas stripped from smaller galaxies that have ventured too close to the Milky Way. These stellar streams, like cosmic rivers, trace out the history of galactic mergers and interactions, providing clues about the Milky Way's growth over billions of years. Section 6: Galactic Dancers, Satellite Galaxies. The Milky Way is not alone in its corner of the cosmos. It's surrounded by a retinue of smaller galaxies, known as satellite galaxies, that orbit our own in a delicate gravitational dance. These dwarf galaxies, like the large and small Magellanic Clouds, visible to the naked eye in the southern hemisphere, are fascinating objects in their own right. The Large Magellanic Cloud and Small Magellanic Cloud are the Milky Way's largest and most well-known satellites. These irregular galaxies are actively forming stars and are a treasure trove of astronomical objects including supernova remnants, star clusters, and nebulae. These dwarf galaxies are close enough to Earth that astronomers can study them in great detail, providing insights into galaxy formation and evolution on a smaller scale. Satellite galaxies play a crucial role in the evolution of larger galaxies like the Milky Way. Over billions of years, these smaller companions can be pulled in by the Milky Way's gravity, merging with our galaxy in a process that adds new stars, gas, and dark matter to our own. These mergers can trigger bursts of star formation and reshape the structure of the Milky Way. The study of satellite galaxies provides valuable clues about the distribution of dark matter in the universe. By observing the motions of stars within these galaxies, astronomers can infer the presence and distribution of dark matter, shedding light on its properties and its role in galaxy formation. Section 7: The Dark Secret of the Milky Way. One of the most intriguing aspects of the Milky Way, and indeed of all galaxies, is the presence of dark matter. This invisible substance makes up a significant portion of the Milky Way's mass, yet it doesn't interact with light, making it invisible to our telescopes. We know dark matter exists because of its gravitational influence on the visible matter in the galaxy. The rotation of the Milky Way provides strong evidence for the existence of dark matter. Stars in the outer regions of the galaxy orbit the center much faster than they should if the visible matter were all that existed. This discrepancy in rotational speeds suggests that there must be some unseen matter providing the extra gravity to hold these stars in their orbits. The nature of dark matter remains one of the biggest mysteries in modern astrophysics. We don't know what it's made of, but scientists believe it could be composed of exotic particles that interact very weakly with ordinary matter. Numerous experiments around the world are underway, hoping to detect these elusive particles and unlock the secrets of dark matter. Dark matter plays a crucial role in the formation and evolution of galaxies. In the early universe, dark matter's gravity acted as a seed, pulling in ordinary matter and causing it to clump together. These clumps of matter eventually grew large enough to form galaxies, with dark matter forming a halo around them. Section 8: A Galaxy is Born. The Milky Way, like all galaxies, has a long and fascinating history, stretching back billions of years to the early universe. While we can't travel back in time, astronomers piece together the Milky Way's history by studying its stars, gas, and dust, like cosmic archaeologists uncovering the remnants of a bygone era. The Milky Way is thought to have formed through a process of hierarchical merging, where smaller clumps of matter drawn together by gravity collided and coalesced over billions of years to form the galaxy we see today. These mergers would have been spectacular events, triggering bursts of star formation and shaping the Milky Way's structure. Evidence for this hierarchical merging scenario comes from the observation of stellar streams in the Milky Way's halo. These streams are thought to be the remnants of smaller galaxies that were torn apart by the Milky Way's gravity. The stars in these streams retain the memory of their parent galaxy's motion, providing clues about the Milky Way's past mergers. The Milky Way continues to evolve, constantly interacting with its surroundings and accreting material from its satellite galaxies. Over time, these processes will continue to shape our galaxy, changing its structure and influencing the evolution of its stars and planetary systems. Section 9. A universe of possibilities, the search for life. The Milky Way, with its billions of stars and even greater number of planets, presents a tantalizing question. Are we alone in the universe? The search for extraterrestrial life is one of the most profound scientific endeavors of our time, and the Milky Way, our cosmic backyard, is a prime location for this search. The discovery of thousands of exoplanets, planets orbiting other stars, has revolutionized our understanding of planetary systems. These discoveries have shown that planets are incredibly diverse, ranging in size from small, rocky worlds to gas giants larger than Jupiter. Many of these planets reside in the habitable zones of their stars, where conditions might be just right for liquid water to exist on their surfaces. The search for life beyond Earth focuses on finding planets that share similarities with our own. These Earth-like planets would need to be rocky worlds of roughly Earth size, orbiting within the habitable zone of a star similar to our Sun. They would also need to have atmospheres capable of supporting liquid water and potentially life. While we haven't yet discovered definitive evidence of life beyond Earth, the sheer number of stars and planets in the Milky Way suggests that the possibility of life elsewhere is high. The search for extraterrestrial life is a daunting but incredibly exciting endeavor, one that could fundamentally change our understanding of our place in the cosmos.